Okay, so we need to talk about non-homogeneous cases since we just powered through the homogeneous case. So the non-homogeneous case would be y prime. Keep in mind I'm playing linear first-order differential equations, right? So the non-homogeneous one would be
y prime plus p of x times y
okay, y prime plus p of x times y
equals some stuff that's not 0.
equals some stuff that's not always 0 at least, right? Okay, versus the homogeneous case. And in the homogeneous case, we had y prime plus p of x, y equals 0. And we did some stuff, right? And we found like y is e to some garbage. Cool. And what technique were we using to do that? Some stuff?
Leibnizing.
Leibnizing and then separation of variables. Okay, so it is going to happen to us a bunch of different times that we're going to have some technique that we're going to like hit a differential equation with, and then I'm going to say, and then you solve it by separating the variables. Okay, so separation of variables is going to be like your quadratic formula. It's like your go-to technique for the end of everything. Cool? All right, so that's what I remember about the homogeneous case. Now, about the non-homogeneous case, there's some weirdness. Okay, this is a little bit harder. So the first thing you do when you're presented with a non-homogeneous case is you solve the homogeneous one. It's not entirely clear why that should help, but it turns out that it's a good idea. Okay, first things first, go over there, solve the homogeneous case. I want to give one wording thing. Given a non-homogeneous differential equation, your book calls the homogeneous equation the complementary equation. If I get around to fixing typos in your book, I'm going to fix that word because it's super aggravating to me. Because complementary means what?
It adds up to, it makes the angle add to 180 or 190 or something.
Yeah, there's a view of complementary in trig-land. There's a view of complementary in like beginning pre-algebra, which is that it adds to 0.
And there's also the complement, right?
And then there's also a thing called a complement in like 3 different fields. Yeah, this word is just too common in my mind. I really wish it was just, why can't we just call it the homogeneous version?
Well, and also like the meaning of complementary that we've been meant to know is like that it completes, but like I think here it's more just like goes along with, right?
Yeah, that it starts maybe. Yeah.
So is the book we're using kind of unique in using that term?
No, this is relatively common. I just don't like it.
Okay. So you want to alter the world to conform to
Why not?
your own predilections?
Yeah.
Right on.
It's totally reasonable. Okay, so first things first. You will take a non-homogeneous differential equation, turn it homogeneous, and solve it. And then once you have done that, you need to run this, and I'm teaching you a technique called variation of parameters. Maybe I should mention that. And variation of parameters is about making a good guess. Okay? So, we are going to guess that our solution, right, looks like y is some function I don't know about. I'm going to call it u of x, multiplied by y h of x, where yh is what? Why would I call it y sub h?
The homogeneous one.
Yeah, it's probably something to do with the homogeneous one, right? That's why you solve the homogeneous case first, right? So this guy is some solution to the homogeneous equation. Cool? Which solution shouldn't it be? Like there, I claim you know that there's a solution that you should never use for this. Yeah, it should never be the trivial solution, right? Because that would be dumb. Because if you plug that in here, right?
Y is just 0.
You're guessing y is 0. Does y is 0 solve the non-homogeneous equation? Hell no, right? Because this is all 0. So you'd get 0 as f. That would mean you're doing a homogeneous equation anyway, in which case, why are you doing more after you already solved it? You guys see that?
Is there some kind of like subscript on that y there?
This guy?
Yeah.
Yeah, that's an h.
Okay.
Your book uses a 1, but I want to use the h to highlight that it came from somewhere. That thing came from the homogeneous version. You guys cool?
How do you get it?
What?
How do you solve the homogeneous cases separately?
Doing the thing that we did. So right now, you guys only know how to solve homogeneous cases with separation of variables. So you should make that homogeneous equation, right? It'll be different. Step over there. Solve it using separation of variables. That solution is going to be your starting point for solving the non-homogeneous case.
How do you turn the non-homogeneous case?
Just get rid of that.
Oh yeah, you just forget the f. Like make it homogeneous by literally just changing it. It's not the same differential equation, right? It's different. That's fine. You start there. Okay, then after you've guessed this, we'll figure out what y prime is. So what's y prime? Okay, yeah, I can get one version from the differential equation. I should also be able to get a version from this thing, right?
Oh, yeah.
So u prime of x times y sub h of x plus u of x times y prime sub h of x.
Is all good with this? Okay, then where are you going to put this information? What's up?
Where did the u of x come from?
I just guessed it. This is the thing about variation of parameters. And actually one of the things about differential equations. Like, my techniques are oftentimes just like knowing which guess is a good guess. Variation of parameters is the technique of knowing that for a non-homogeneous equation, a good guess would be to take your homogeneous equation and multiply by some other function you don't know and then solve for that.
Would that u of x always have to be linear in the x? Like a
No.
first, no? Okay.
So what do you do with this? You guys told me just a second ago you knew what y prime was another way, right?
Yeah.
Plug it back into
Plug it
the.
into.
Okay, so if I think this is a solution, I should take this and plug it back into the differential equation, right?
Yeah.
Okay, so 3 was just calculate y prime, right? Step 4 is going to be substitute. So if I substitute, I should get u prime of x times yh plus u of x times yh prime.
Plus
So what was all that, Jazz?
that
It's the y.
y prime.
That's just the y prime, right?
So that plus p of x times y.
So that times, so I got p of x times, what was y now?
The u of x
Yeah.
times.
Y was u of x times yh, right?
Yeah. Should equal f of x.
And then this whole thing should equal f of x, right? And now which is my unknown? Because there is a massive ton of stuff kicking around here.
U of x.
Yeah, u of x is the thing I'm trying to solve for, right? So, what can I notice here? I claim that there's a thing worth noticing. Oh, whoops, and I just erased the part that was going to be the hint.
You can factor.
Hint, I erased the hint.
You can factor a no.
Okay, let me rewrite this whole business up here so I can get at it clearly. So I've got a u prime of x, right? And then a yh, and then I've got a plus u of x, and a yh prime, and a p of x, and a u of x, and a yh regular. And this is supposed to be f, right? You guys see that? And so my claim is that step 5 is notice. What should you notice?
That's like kind of like a differential equation in use, like a linear one.
Yeah, this is kind of a differential equation in use, right?
Yeah.
If I got rid of the y's, well, if I got rid of the yh prime, right? This would be a first order linear differential equation in u, right? Okay, in what world would it make sense to get rid of the y's? Just gotta notice something about yh. What do you know about yh?
Equals 0.
It doesn't equal 0, because it's not the trivial solution. But what does it solve? Yeah, it solves the homogeneous version, right? What was the homogeneous version? Like if I thought about the homogeneous version, it's yh prime plus p of x times yh equals 0. So this is what I know, right? I know this blue thing. You see that blue thing kicking around somewhere? Like there's this, that's your yh prime, there's a p of x times yh. Oh, I could factor a u out of that stuff. You guys see that? So this stuff here is u of x times 0. Which is 0, right? So what you get is you got u prime of x times yh is f of x. Okay, so for a second there, right, I thought I had traded a first order differential equation in y for a first order differential equation in u. And I still have. But why is this one better than the one I had in y's?
You should know both of those on the left, right?
Yeah, so I know these two things, right? Like I know yh because I solved the differential equation, I got a solution. I know what f is because I just read it out of the equation I was posed, right?
And you find u.
I think I need to find u, right? So I should just solve for u. You guys see that? So how do you solve for u here?
Just divide by y.
Yeah, divide by yh. So you get u prime of x is f of x over yh, really is a function of x, right?
And then integrate.
And then integrate, because you just want to drop the derivative. So why was this equation better than the one I had at the beginning?
It's like you can find the solutions.
At the beginning I had a y prime and a y, right?
It's non-linear.
It was linear, it was just annoying because it was first order and 0, right? It had a first order piece and a 0th order piece, whereas this guy only has a first order piece. So you can just integrate to get rid of it. You don't have to separate variables or any other such nonsense. You guys see that?
So what are you going to do with respect to?
X. Because what did you differentiate
Oh,
with
yeah,
respect
yeah,
to?
because they're all, yeah.
So does this turn into a nightmare when you have two variables?
Oh yeah. Yeah, that's why we don't solve partial differential equations in this class. We do regular differential equations. That's one variable. If you want to do partial differential equations, get a master's degree. And I didn't take that class, by the way, and wouldn't ever.
Wow.
Okay, so if you want u of x, how do you get u of x?
Integrate fx divided by.
Yeah, you integrate f of x divided by y h of x dx, right? Okay, and I wish I had more time, but I don't. So you don't get an example. Sorry, guys.
Is our homework just to take